Today we are going to discuss the STPM format questions. Same as the question given. Show that the equation x to the power 4 minus 2x to the power 3 negative minus x plus 1 equal to 0 has at least a real root in the interval 2 and 3. For this part, we have to use or we have to apply the intermediate value theorem to solve. Then followed by the determine which of the interaction xn plus 1 equal to xn to the power 4 minus 2xn to the power 3 plus 1, or the other interactive formula xn plus 1 equal to 2xn to the power 3 minus 1 over xn to the power 3 minus 1 in more likely to give a convergence sequence of approximation to a root in the interval 2 and 3. Use your choice with initial value of x equal to 2.5 to determine the root correct to 3 decimal place. For the first part, we apply the intermediate value theorem to solve. So we let the f of x equal to the equation x to the power 4 minus 2x to the power 3 negative x plus 1. First, we substitute the x equal to 2 into the equation. So f of 2 equal to negative 1. That is less than 0, so it's a negative sign. Then we follow up by substitute the x equal to 3 into the equation. So f of 3 equal to 25. That is greater than 0. That is a positive sign. F of x is a continuous function, and we have the proof that there is a change in signs of f of x from negative to positive. Then we can conclude that the equation x to the power 4 minus 2x to the power 3 minus x plus 1 equal to 0 has at least a real root in the interval 2 and 3. The following solution. We want to determine whether the given iterations is convergent or divergent sequence. So we have to do the differentiate for the iteration with respect to x, and then substitute the initial value x equal to 2.5 into the derivative. If the modulus of the derivative is less than 1, mean there is a convergent sequence. If greater than 1, there is divergent sequence. First iteration given is xn plus 1 equal to xn to the power 4 minus 2xn to the power 3 plus 1. So we let the iteration rewrite into the function f of x equal to x to the power 4 minus 2x to the power 3 plus 1. So we do differentiate with respect to x, the function given. So f prime x equal to, we apply the standard rule of differentiation to solve. So we have the 4x to the power 3 minus 6x to the power 2, followed by substitute the initial value x equal to 2.5. So we have the f prime 2.5 equal to 25 after do calculation. So the answer is greater than 1. So we can make conclusion there is a divergent sequence. Second interaction given is xn plus 1 equal to 2xn to the power 3 minus 1 over xn to the power 3 minus 1. So we apply the quotient rule u over v to solve the function at the right side. So we differentiate the function f of x, we have f prime x equal to, we differentiate the u, we have the 6x squared, then v x to the power 3 minus 1 minus, differentiate the v, we have 3x squared, then multiply with the u, 2x to the power 3 minus 1 over the v square, x to the power 3 minus 1 square. Then we follow by the factorization. We factor out the 3x square. So we have 3x square bracket 2 bracket x to the power 3 minus 1 minus bracket 2x to the power 3 minus 1 over x to the power 3 minus 1 to the power of 2. Then after do simplify, we have the answer f prime x equal to negative 3x over x to the power 3 minus 1 square. Then the following step, we substitute the x value 2.5 into the first derivative of the second iteration. So we have the f prime 2.5 equal to negative 0.0877. So the modulus for your f prime x is less than 1. So we can conclude that the iteration given is convergent sequence. Therefore, the iteration xn plus 1 equal to 2xn to the power 3 minus 1 over Sn to the power 3 minus 1 is more likely to give a convergent sequence of approximation to the root in the interval 2 and 3. The last part of the solution, we want to find the approximation for a root by use the iteration formula xn plus 1 equal to 2xn to the power 3 minus 1 over Sn to the power 3 minus 1. Given that the initial value of x equal to 2.5. So we do the calculation. So when n equal to 0, we have the x1 equal to, then we substitute the x equal to 2.5 into the formula. Then we have the answer 2.06837. Then we continue the following solution. When n equal to 1, we obtain x2. So do the calculations as the previous calculation. We have the answer 2.12740. Then we do the further solution until we get the x4, x5 are in the approximation, same approximation when correct to 3 decimal place. So the root equal to 2.118, correct it to 3 decimal place.